Hello and welcome to another study session of chemistry. Yes, this is part two of Let's Study in Chemistry, and we're gonna do just that. So let's do it. So methane reacts with oxygen according to the following equations. The energy change for this reaction is best described as it's a combustion. So all combustions are exothermic, because the net strength of the bonds in the products is greater than the net strength of bonds in the reactants. No, that's angular. Yes. No, what? What? Doesn't make sense. Wait, what? Yeah. The products are more stable than the reactants and thus at a lower energy, so lower net strength. Hence, the products have stronger bonds. Wait a second. HP, net strength of the bonds in the product. The net strength of the bonds in the products is greater, so you need more energy. I am so confused. Anyways, next. Which of the following equations best represent the incomplete combustion of ethanol? Well, should be um no CO2 doesn't make CO2, makes carbon monoxide. This what? Carbons. What? So when C is produced, just solid C. Oh, that's when it's incomplete. Okay. Next, which mole of oxygen consumed, which one of the following fuels produces the largest amount of carbon dioxide? This one. What? You fine. Why is it you fine? Equation for the I have to do it manually. Oh my gosh. E fine is the way you have to balance it is so weird. All right, next. Partial oxidation of methane is one step in the production of methanol. So methane plus oxygen gives you carbon monoxide and hydrogen gas. That's the enthalpy change in enthalpy. The activation energy for this reaction is 32 kilojoules per mole. The energy profile for this reaction is best represented by, so it's negative. So it should be at the bottom. So it can't be that. Be this or this or this. So from here to here, the displacement be the negative 74, but there's a 2. Divide that by 2. Why do you divide it by 2? What did I just do? What did I do? Oh, what? That was a guess. Why is it though? Since the reaction is, yeah, I get that. The energy of the products, yeah, I understand that. Okay. The top of the curve must be, the activation energy. Oh, so here's, okay, I get it. I understand. Ooh. All right, makes sense. Okay, sleeping. The energy, did it again. The energy profile on the following page shows the results obtained during an enzyme catalyzed reaction. Each stage of the reaction is labeled M, represents the initial reactants, N represents a stable intermediate, and P represents the final products. Okay. The energy change from M to N is exothermic, doesn't look like it. The energy change from M to what? B greater than H. Positive, endothermic. There has to be endothermic. This one, this one. And the energy change from N to no. Yes. Yeah, I understand. Finally. So many questions about profile diagrams. Yeah. Oxidation of sulfur dioxide is an exothermic reaction. Okay. The reaction is catalyzed by vanadium, V oxide. Which one of the following energy profile diagrams correctly represents both the catalyzed and uncatalyzed reaction? It can't be that. It can't be that. But what's the difference between what happened? Oh, I got it right. Do they start from the same exothermic reaction? The enthalpy of the products is lower than that of the reactants. Yes, that's correct. A catalyst, a catalyst lowers the peak of the energy profile, but neither the entropy of the reactants nor that of the products is changed. So when you put a catalyst or uncatalyzed, doesn't matter. It's always going to have the same change in enthalpy. But a catalyst lowers the peak of the energy. So if you add a catalyst, you require less activation energy to produce a chemical reaction. But the displacement from here to here has to be the same. So from here to here, but from here, you see, it's different. They're not the same. But here is the catalyst. Catalyst, yeah. It's be less, yeah. Okay. Wait, is that all? Wait, all about profile diagrams. You serious? Oh, this is multiple choice. Anyway, is this? Wait, did I do this one? Oh, is it this card? Is wait. I think I've done these questions. Yeah, I've done these questions before, but which one am I up to? I don't know. Um, because of the polarity. I just uh, I'll go back to that question. I already did the question. I just want to do it again. Which one of the following is a biofuel? No, not this one. Obviously, natural gas is from crude oil. Methane, ethanol. I think I already knew that answer before. Biodiesel and petrodiesel have different viscosities. Yeah, have the same. No, contain. No, no. All right, wait. Okay, I've done those questions, but which questions have I? What does this say? Calculation involving fuels. Okay, I guess I'll just do that. I have that. I also have Neep. I can use Neep. Let's use this. Let's do this though. All right. Under these conditions, so temperature is that. All neon atoms have the same kinetic energy. The average kinetic energy of neon atoms is different from that of other gases under the same. Is it though? I don't, I don't think so. The average kinetic energy of neon atoms is proportional to the temperature, probably. Percentage of atoms with high kinetic is higher than it would be at the same pressure and volume and a temperature of 40 degrees. Well, I don't get it. All right, whatever, man. Next, that's scaring me. Equal amounts of sulfur dioxide and oxygen are at the same temperature and pressure, both gas samples. So at the same temperature and pressure. All right. All molecules move at the same velocity, contain equal. I'm saying molecules. Yeah. Yes, I did it. All right. Volume occupied by 1 mole of fluorine gas is approximately double the volume occupied by. Do I have to get my thing out? Argon. Argon. So 39.95, so 1 mole. Helium. There's only one. Helium is not diatomic, is it? No, it's not. Yeah, I did it. I'm so done with these questions. It hasn't even been like that long as well. All right. 100 milliliters of ethane gas. Oh my God, I remember this question. All right, let's try to do this question again. All right, so what are we looking for? What is the total volume? All right, so 100 milliliters of ethane gas was mixed with 500 milliliters of oxygen gas at 20 degrees Celsius and 1 atmospheric pressure and spark. The direction shown by the following direction occurred. What would be the total volume of gas present when the reaction had cooled to the original temperature and pressure? Mm, 100 milliliters. So one, how can I say this? That's moles. Get the mole and divide it by the coefficient. So to get the mole, that's the mole, isn't it? Yeah. So 100 divided by 2. 500 divided that by 7. So oxygen is in excess. Limiting. Unknown over known. 4 over 2 is 2. 2 times. I got a notification. All right, anyways, moving on. 2 times 100. Um, that's for carbon dioxide. So 200. That's what I got, 200. Wait, how am I gonna? What was that noise? I got a fat cat. All right. So 500 is total. We have to find how much was reacted. So How are we gonna find excess amounts of oxygen? Because we found the total. Here the total that's given. Mm, oh, wait a second. Unknown over known. Unknown over the limiting reactant. 7 over 2 times it by 100. So, oh, okay. Okay. That's the volume of oxygen that's being that's reacted to 500 minus that gives the remaining the product. To find the volume of that, phone times it by, yeah. All right. It's a good question. It's a pretty good question. When hydrochloric acid is added to the highly toxic gas hydrogen sulfide is evolved, the equation is that if excess hydrochloric acid is added to zero point 0.2 moles of aluminum sulfide, then the volume of hydrogen sulfide produced at that will be the amount of moles equals the volume divided by the mole volume. Mole volume is 24.8. We just have to find the amount of moles of hydrogen sulfide and to find that, what are we given? If excess hydrochloric acid, so this is the excess, 0 0.2 moles of, so that's given. So unknown, over known, so 3 times zero point 0.2, that's the amount more. Get that, times it by 24.8, and we got 14.9. It's a big number. I don't know if I'm correct. I am correct. Yay, I'm too good at this, man. An acerola can with a volume of 300 milliliters contains 2.8 grams of propane gas as a propellant. So, what are you doing, man? You're interrupting my study session. Hey. Oh, okay. Hello. Um, can I? Okay. So the warning label says the acerol may explode at temperatures above 60 degrees. What is the temperature in the can? What is the pressure in the can at a temperature of 60 degrees? Just looking for pressure. Now, remember the formula. PV equals the gas thing, which is 8.31 times temperature times the amount in moles, R and T. So, hello. So, 400 milliliters converted to liters, point 0.3. Uh, propane gas, propane. What's the molar mass of propane? This propane is free carbon. Propane, three times two plus two, 6 plus two, 7, 8. So 8 plus 12 times 3. That's times 2 times 3. Because there's methane, ethane, and propane. 44. I do 2.8 divided by 44. Yeah, go away. Anyways, right, right. Um, so that times it by the Celsius. Well, that's it. It's going to be Kelvin. So 60 plus 273 has to be in Kelvin. So this times it by the moles, 0.06, times it by 8.31, and divide that by zero point 0.3. I've got 586, 5.9, 5.87. Too easy. Just too easy. Too good too good at studying. Let's study. The emergency oxygen system in a passenger aircraft uses the decomposition of sodium chlorate to produce oxygen at 76 kilopascal and 292 Kelvin. Each adult passenger needs about 1.6 liters of oxygen per minute. The equation for the reaction is that the mole mass is for sodium chlorate is that the mass of sodium chlorate required to provide the, the, no, don't step on my laptop, please. Uh, to uh, mass of sodium chloride required to provide the required volume of oxygen for each adult passenger per minute is okay. So what do we need to know? Mm, let's see. The mass of sodium chloride, that's what we're looking for. So oxygen is 1.6. Are we looking for temperature? No, wait, temperature's given. We're trying to find the amount in mole of oxygen. Okay. All right. So let's do this. So 76 kilopascals. So 292 Kelvin times that by 8.31, right? Now do 1.6 times it by the kilopascals, 76. Now we get that number. We divide it by this number, and we get the amount of moles, which is 0.05 for oxygen. For oxygen. So now we use that to find the amount of mole of sodium chlorate. That would be, so mass of oxygen is that, coefficient, unknown over known, 2 over 3. So um 2 over 3, so 2 times this divided by 3. Get this, times it by 106.5. I got 3.56. Yeah, I'm correct. I'm always correct, man. Amazing. Anyways, methane, ethane, ethine, and propane have all been used as fuels. The enthalpy change for the balanced complete combustion reaction of these fuels is given by the following equations. When 1 gram of each fuel is burnt, then the fuel releasing the greatest amount of energy would be when 1 gram. One, uh, what's the formula? Oh, wait, releasing. So, what's the guy doing? I got a weak cat, man. I don't know what he's doing. What are you doing? Hey. Anyways, okay. Formula. All right, you know what? I completely. Is it Q? After we change, what's the formula? Just want to know what the formula is. What? All right. Uh, enthalpy change equals Q over N. So Q equals enthalpy change times mole. All right. 1 divided by, all right, so methane. So it's 12 carbon. So carbon is 12, hydrogen is 1. So 12 plus 4 is 16. Now we do 1 divided by 16. Get that. Multiply that with the FB change, which is 190. Now 55.6. Now let's do that with 1 gram. All right. 12 times 2 plus 6. 1 divided by that. Times it by 3. 1, 2, 0. Way bigger. 12 times 2 plus 2. 1 divided by that. Times it by 2,600. Nope, the second one's still bigger. So 12 times 3 plus 8. 1 divided by that. Times it by 2208. All right, my final answer. Why? Wait, is it because you have to... Oh, wait. Oh, 250. Oh, is that why? Oh, yeah, coefficients. I forgot about them. Divided by 2, that's how you get the... Oh, yeah, my bad. Both ethanol and methanol have been suggested as alternative fuels for transport vehicles. The equation describes the complete combustion of ethanol and methanol. Uh, Separate experiments. My nose is dry, man. Anyways, so dark. Wait. Hey, spider. I know. I know. Yum, 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 yum. All right, let's go. Let's continue on. So, separate experiments are conducted in each in which 1 mole of ethanol and 2 mole of methanol undergo complete combustion. In these experiments, the combustion of methanol is small carbon dioxide. The combustion of methanol produces more carbon dioxide. Now let's test that if it produces more carbon. 2 moles of methanol. Uh, unknown over unknown over known. Unknown over known times by 2. Just 2. 2. Unknown over known 2 times by 2 is 4. So an unknown over known times by 1. That's 2. So they're the same. So no, they don't. They produce the exact same carbon dioxide. More heat energy is released from the combustion of ethanol. That's not true. More water is formed in the combustion of ethanol. So unknown of known, three. Three times one is three, so three. Two. Unknown of knowns, two. Two times two, four. Unknown of known, three times two divided by two. Unknown of known is three. Three times one is three. Yes, yes. My God, I have to go to the last question. My goodness. The heat of combustion for three methyl esters is given in the table below. One of the molecules found in biodiesel is methyl. That the best estimate for the heat of combustion. What are you doing, man? Go away. I gave you food. I even gave you milk. What time? How long have I been doing this? I can't tell. Anyways, we'll do a couple more questions. Yeah. One of the molecules found in the best estimate for the best estimate for the heat of combustion is estimate. All right, we're making an estimate. All right, so it increases as carbon increases. Or the difference between 4211 minus 3558 is that, and 4863 minus 4211. It's like 650, something around there. So 17 minus 6. So that times it by that. The, I'm getting confused. Plus 4863 equal B. Is it B? Oh, it is B, thank goodness. Oh, all right, I think I understand. Okay. 2013 passage. Given the information above, what is the enthalpy change for the following reaction? What is the enthalpy change for the following reaction? Oh, wait a second. C, H2O. What's the difference? I'm gonna say it's combustion. I want to say it's negative, so I want to say 39 3.5. No, wait. Mm, Actually, oh my God, I got it correct. Whoa. Okay, so this is how it is. That says negative because this is on the right side. I'm looking at the products. Well, that's a really good question. Bioethanol. How many questions are there? There's so many questions. 2018. Oh, okay. Bio, bioethanol is produced by the fermentation of glucose according to the following equations. The mass of that obtained from the mass of so 12 plus 16 times 2 times 2. 5.68 divided by that. And unknown of a known. 12 times 2 plus 5 plus 6 plus 16. This times that. I've got 5.9. Look at this. Yeah, yeah. It's not hard, man. Too easy. Large deposits, methane. Amount of energy released by the complete. I think it's better to make a thing. For complete combustion of methane, CH4 plus uh, O2. That gets you CO2 plus CH4 at little dots, 6H2O. Um, Balance equations. So we've got four hydrogens. Actually, wait, we got one carbon there, one carbon there. Got four hydrogens here. Got Wait, we got a carbon here too, right? Yeah. We actually have one, three, actually one and two, 12, 16, 16. So 4, 8, 12, 16. Times this by 4. Say if I times this by 4, there's 4 carbons here. There's 2 carbons here. By times this by 2. 2 carbons. I don't know what this cat wants. What do you want? What about it? I'm trying to work. I'm trying to work. Uh, I'm afraid he's gonna like pee somewhere, so I don't want that to happen. Um, times times by three, three carbons, one carbon, four carbons. It's four carbons there. So yeah, times by three. That means I have six. Three times two is six. Six times one is six. Six plus six is 12. Got 12 oxygens here. Times this by six. Now it is balanced. All right, coolio. Just want to make sure. So 16, six and two, 12. Yeah, okay, all right. So now what does it say? 1 kilogram sample of methane from methane hydrate. Okay. Wait, did I even need to do this? No, but I needed the, so confused. Wait, wait, stop annoying me. Don't be anywhere. I'm really finished. Um, mm, I can get the mole. I meant a mole of methane hydrate, but I need to multiply that with the heat of combustion. So is it, what do I do? Okay. So 12, 6 plus 16 plus 16, 1,000 divided by that, because that's going to be that much mole. But so confused. I'm so confused. Yeah, wait, what? Where do you get 124 from? Unknown. What is it? I'm just trying to figure out why it's 124. So is that, wait, is that dot? Is that a times? Wait, 12 plus 4, yeah. 16 plus 16. No, no. Where did they get 124 from? You stop. Wait, SLC. Oh, wait. The millimole is. No. Wait. To find. Can you stop? Can you stop? I'm trying to think. Let's cat. Ah, I'm so angry. Oh my god. Right. Used. Where did 124 from? 124, that's a molar mass. So number of moles of methane equals number of moles of methane hydrate. Oh my God, I'm such an idiot. Oh my God, I'm so dumb. That six right there is timesing of the hydrogen and the oxygen. I completely forgot about that. Oh my goodness. Anyways, I can't believe it took me like half an hour to figure that out. So 8.06. Okay. Now the complete combustion, yeah, that's given to you, which is 890. Thumbs up by 890. And there you go. All right. How many questions are there, man? 14, 24. Damn. It's crazy. Which question are we up to? All right, you know what? I think that's enough questions for today. All right. But that concludes Let's Study Part 2 of Chemistry. Okay. So yeah, I hope you guys learned something new. Even though I wasn't really explaining much, I was just looking and doing things. And anyways, I appreciate you guys listening and watching my Let's Study session. And yeah, I'll see you guys in my how do I no stop share. Ah, okay, stop share. All right. Hello. Wait. Hello. Okay. So I'll see you guys in my next study session, and it'll probably be about specialist. It will be about specialist. We're gonna do vectors, and yeah, we're just gonna do vectors. All right. I'll see you guys in my next study session. Bye bye.